Hey guys, it's EJ with Blockpad, and in this video we're looking at complex numbers. So to get into it, Blockpad uses a pretty intuitive approach to complex numbers where you're just going to use I or j as the imaginary number, which represents the square root of -1 inside of the formula. So here I have three examples of doing just that. If I click into these formulas, you'll see I just have the letter I, or in this one, I have the letter J typed in. It's pretty straightforward. So going back to this top one, I can also, for example, just type in 4i, and that's also going to work. So then if I tab over, I can press the equal sign. I can reference this value and take the square, and then I'm going to get my answer. Of course, I can just type these numbers directly into the formula without creating a value like that. So for example, I could say open parentheses 4 plus 2i squared, and that's going to give me a result. Or I could take the sign of 1 plus I, and that's going to give me a result as well, and so on. You can also use the complex or polar functions to generate a complex number. So the complex function is going to take the real and imaginary components and generate a complex number. And the polar function is going to take the magnitude of the complex number and the angle. And then from there, it's going to generate a complex number with the real and imaginary components calculated from that. You can also just take the square root of a negative number, and that will give you the imaginary number in your equation. So here I have 3 plus the square root of -4. You can see my answer. Or I also have -16 raised to the exponent of 1 divided by 4, which is the same as taking the fourth root of this negative number. So my result has the imaginary number. Now, when you're using units with a complex number, you're going to want that unit applied to the entire complex number. And to do that, you're going to put parentheses around the complex number and then the unit typed in afterwards. So here I have parentheses 5 plus 3j, close parentheses, and then W for watts. I could just type in any old unit here. So for example, I'll press Control backslash and start typing in omega, press enter, and so now that value is in ohms. Also be mindful of units if you're taking the square root of a negative number, because the units of that negative number will also have that unit math taken care of. So here I have 3 watts plus the square root of -6 watts squared, because when I take the square root of watts squared, then I'll get watts as my result. Now you should also take some care when using units with the complex and polar functions. For the complex function, you'll want both of those inputs to have the units you want because it represents the real and the imaginary component. The polar function is going to be a little bit different. Because of the math involved, you're only going to want the units on this magnitude input. The second input, the angle, should either be unitless or it should have degrees or radians. So here in this example, my first input has ohms. So you see in my result, ohms are applied to that total complex number. Now, just one more option that I want to point out is that you can also use the approach of multiplying by 1 with the unit you want. So for example, if I want to avoid using units inside the complex function, then I can do that and then multiply this times 1 watt, and then that's going to have the same effect as what I had previously. Moving on, there's not a bunch to say about display for complex numbers, but I wanted to point out that any value format decimal controls are going to apply to the real and imaginary components together. So if I select this, and for example, decrease digits or increase digits, then that's going to apply to both of those together. Something that could be useful here if you have a big difference between the real and imaginary, so let's say I multiply this by 10,000, is you could use significant figures. So I'll go to value format, and I'll say a fixed count of 3 significant figures and click OK. And so that 3 significant figures is going to apply to both the real and imaginary instead of a strict decimal control. Moving on to doing calculations with complex numbers. So basically, all of the math operators that work for regular numbers are also going to work for complex numbers and they'll handle the math correctly. So here I have ZA and ZB. You see I can add, subtract, multiply, divide, and take the exponent of these complex numbers, and all of that is going to work appropriately. Now, when testing complex numbers for equality, you can test if two complex numbers are equal or not equal, but you can't test for greater than or less than. If you really need to compare complex numbers, you'll have to compare their components, like the real or imaginary component taken by those functions. Speaking of those functions, I have them listed down here. So we have the real, imaginary, absolute value, and argument functions, and those are going to return the real component, the imaginary component, the magnitude of the complex number, and the angle or argument, respectively. So you'll use those 4 functions to kind of take out the information from complex numbers, sort of like the inverse of the complex and polar functions, which you use to generate complex numbers. Also, basic math functions are going to work with complex numbers, so things like the square root, the nth root, log or natural log, all of that stuff is going to work. Trig and hyperbolic trig will also work on complex numbers in Blockpad. There is one thing I wanted to point out though. So if I press the equal sign here and take a cosine of 2, then I get NaN as my answer. I look at the error bar, it says number error, essentially saying there is no arc cosine of 2. But if I come here and say 2 plus 0i, so now my input is a complex number, even though the imaginary component is 0, Blockpad's treating it as a complex number. And so when I do that, then I get an actual answer for arc cosine that is a complex number. So just something to be mindful of with those inverse trig functions. Sometimes you'll want to make sure that input is a complex number if you want a complex number result. One last thing I wanted to point out is that rounding functions are going to apply to the real and imaginary parts of a complex number together, a lot like the value format decimal applies to them together. So here I have ZD. If I round it to the third decimal, you'll see that rounding happens on the real and the imaginary component. And with that, that's all I've got for you guys today on complex numbers. Please let me know if you have any questions in the comments. Thank you.